So this is the last section in chapter 18. We will spend inshallah 2 lectures with this section as it's a little bit long. We will know how to write formulas, the chemical formulas, and how to name the compounds. It's called writing formulas and naming compounds. So we will study 3 things here. How to calculate the oxidation numbers, and what are the oxidation numbers also, how to calculate it, how to name a chemical compound. If you have a chemical compound like NaCl, like MgCl2, how to name these compounds, and how to write a chemical formula. If I told you that there is a sodium chloride, for example, how to write down the chemical formula for the sodium chloride or for the other compounds. There is a method. So let's start with the oxidation numbers. So before we can write a chemical formula, or before we write down the name, we need to know 2 information. What are these information? The elements in the compound. How many elements in a certain compound? Okay. What are these elements in the compound? Like NaCl. It has 2 elements, sodium and chlorine. Okay. And also we need another very important information. A very important information. What is it? The number of electrons these atoms gain or lose or share with each other to become stable. The number of electrons they gain or lose or share to become stable, which is called the oxidation number. We call it the oxidation number. So the oxidation number is what? Guys, could you please turn off the microphones? Turn off your mics, please. Thank you. Just turn it on when there is a question that you need to answer or when you need to ask a question. Other than that, please turn it off. Thank you so much. So, oxidation number is a positive or negative. It might be a positive or negative number. It indicates how many electrons an atom gain or lose or share with the others to become stable. Okay. So how many electrons? Oxidation number is a positive. Might be a positive number or a negative number. It tells you what? How many electrons the atom gains or lose or share with the others. Like in case of NaCl, okay, the Na gives an electron to the chlorine. Na becomes a positive one and the Cl becomes negative one. Do you remember that? So we say what? We say that in the oxidation number of sodium is positive 1 and the oxidation number of chlorine is negative 1. Another example, MgCl2. Mg gives 2 electrons, okay, and those two electrons, they are taken by 2 atoms of chlorine. So each atom becomes negative 1. Each atom becomes negative 1. How do you know that they are balanced? The magnesium gives 2 electrons, and we have 2 atoms of chlorine. Each chlorine accepts 1 electron, so 2 times negative 1, that's minus 2, equals to 0. So 0 means they are balanced. 0 here means they are balanced. Okay? So that's magnesium chloride. And the oxidation number for magnesium will be positive 2 and for chlorine is negative 1. So these are for the ionic compounds. The ionic compounds, when they gain and lose. The metals, they lose. And the non-metals, they gain. Okay? What about sharing electrons? Sharing. In case of sharing, we said last time, in sharing electrons, they make covalent bond. And there are two types of the covalent bond. What are they? What are the two types of covalent bonds? Excellent. So we have polar and we have non-polar. Non-polar like Cl2. Okay. In the Cl2 we have Cl with Cl. Each one shares an electron. Okay. Each one shares an electron. So in this case, if each one shares an electron, and both atoms are the same, they have the same strength, they have the same electronegativity, as they are identical. So in this case, no one becomes more negative than the other, and no one becomes more positive than the other. So we say that the oxidation number is 0 for this one and for this one. Oxidation number of the two atoms, 0. That's for the non-polar bond. Okay? But what about the polar bond, like HCl? In the HCl, H shares an electron with the chlorine, right? They share electrons. So they make a bond, covalent bond or molecular bond. But chlorine is stronger. Chlorine is stronger as it has more electronegativity. So it pulls the electron more, so it becomes a little bit more negative. And the hydrogen turns into a little bit more positive. Okay? So we say here that the hydrogen has positive 1 and the chlorine has negative 1. So these are the oxidation number of hydrogen and chlorine in the HCl, or when they share electrons. Understand it? There are some rules that we will discuss together. Some rules for the oxidation number. What are they? Number 1, for binary ionic compound. Binary means it has two elements, like NaCl, like MgCl2. It has two elements, magnesium and chlorine. Like Ki, potassium iodide. Okay? All of these are binary ionic compounds. They have metal and non-metal. Binary bond, ionic bond. So we call it binary ionic compound. Okay. So for the binary ionic compound, the oxidation number of the elements is the same as the charge of the ions. Like we said, NaCl. Na is positive 1 and Cl is negative 1. So this is the oxidation numbers. As we said, MgCl2. Mg is positive 2 and Cl is negative 1. So that's the oxidation number is positive 2 and negative 1. Okay? Total, the second rule says what? Total number of oxidation numbers is 0 in the neutral compound. In the neutral compound, like NaCl, MgCl2, Ki, LiF, all of these are neutral compounds. Neutral compounds. Okay? In these neutral compounds, the total oxidation number is 0. As I said before, okay, I think I erase it. We can do it here. NaCl. Na is positive 1 and Cl is negative 1. So positive 1 minus 1 gives you 0. So that's a neutral compound. If we take the MgCl2, we have one atom of magnesium. It has oxidation number positive 2, so 1 times positive 2. And 2 atoms of chlorine. Each one has negative 1, so minus 2 times 1. It also gives you 0. Okay? You understand it, guys? So the total number of oxidation number, or I can say the sum of oxidation number is 0. Sum of oxidation number is 0 in the neutral compounds. Questions? Do you have questions? Nothing? Are you sure? the other rules. Number 3. For a single neutral element, oxidation number also is 0. Like what? H2, Cl2, O2. Why, guys? Why for the H2, Cl2, O2, N2, whatever, something that has 2, it has 0 oxidation number? Can you answer this question?
Because it is identical.
So if it is identical, what will happen?
Non-polar.
It's non-polar. Non-polar bond, because it's non-polar bond. Right. Also for the single atoms, like Na, the sodium, the magnesium, the iron, the copper, all of the elements, as long as they are single and neutral, so they have no oxidation number. They have no oxidation or oxidation number, as long as they are neutral and single. Number 4, monoatomic ion. If it becomes an ion, if the element or if the atom becomes an ion. Mono, do you know what the meaning of mono? Mono means one. Means one, that's right. So monoatomic ion, the monoatomic ion, its oxidation number is the charge. Like sodium, positive 1. It's in the first column. Magnesium, positive 2 in the second column. Okay? So we say here, group number 1 or column number 1, their oxidation number is positive 1. Group number 2, oxidation number is positive 2. Okay? So these are the first 2 columns in the periodic table. If we look at the periodic table here, we said first column, it has positive 1. Second column has positive 2. Of course, the first one except hydrogen. Except hydrogen. Hydrogen has a special case. Sometimes it's 1, sometimes it's negative 1. Okay? Column number 13. Number 13 is positive 3. Okay? Column number 14 is positive 4. And this is the most common oxidation number. The most common oxidation number, because sometimes it's different. Sometimes it's different. Okay? With column number 15, the most common is negative 3. Column number 16, negative 2. 17, negative 1. 18, 0. Why column 18? Why column 18 is 0, guys? Why do you think column 18 has 0 oxidation number?
Because it's stable.
It's stable, that's right. Column 18 has its outmost level full of electrons. Full of electrons. Here, helium, it has 2 electrons. 2, 8, 8, 8, 8, 8. So these levels are full of electrons. And this level also, as it's the first level, it's also full of electrons. Okay? So they are, and they do not need to react, they are stable by themselves. So they have 0 oxidation number. Why column number 17, the halogens? The halogens, what happens? They have 7 electrons in the valence level. They have 7 electrons in the valence level, or the outmost level, or outmost orbit, or shell, whatever name. Okay? So they pull 1 electron from the others. They try to pull 1 electron from the other elements. And because they have high electronegativity, they are non-metals. And they have high electronegativity. If you remember, fluorine is the highest. And cesium, it was one of the lowest. Okay? I think cesium or francium. I'm not sure. I think the cesium. It was the cesium.
I think it's the lowest.
Francium?
This is the least.
I'm not sure. I'm not sure. Like it's not a big deal. It was like 0.7 or something. Anyway, so the halogens, they have high electronegativity. So they are strong atoms. So they pull the electrons. They usually pull the electrons from the others. Except the oxygen, because oxygen is very, very strong. Oxygen is number 2 after fluorine. Fluorine is the strongest ever. Oxygen is number 2 after fluorine. So if we neglect the case of oxygen, they can pull the electrons from the others. So they become negative one because they pull one electron from the other atoms. Okay? Do you have any question on this one? So now we know this stuff. So oxygen, negative 2. Oxygen, negative 2. And halogens, negative 1. Halogens, here, they are negative 1. Okay? Okay. So I need you to remember the oxygen because most, like 99.99% of all the reactions of oxygen, it's negative 2. Okay? So whenever I ask you what's the oxidation number of oxygen, you say negative 2. Okay? Except maybe some few reactions, some very few reactions like H2O2 or something like that. Okay? But other than that, oxygen is negative 2. Okay? Halogens, they are negative 1, except with oxygen, because oxygen is stronger than most of them. Okay? But other than oxygen, when it reacts with anything else, it's negative 1, because they only need to pull one electron. Okay? What else? Hydrogen. We said hydrogen is a special case. Hydrogen, it might be positive 1 or negative 1. Sometimes it's positive 1 and sometimes it's negative 1. Positive 1 with metals and negative 1 with metals. Can you tell me why, guys? Why with non-metals it's positive 1 and why with most of the metals it's negative 1?
It has higher electronegativity than the metals.
Yeah,
All the other electrons.
it has electronegativity around 2.1. That's right, which is higher than most of the metals, or maybe it's higher than the metals in general. It's higher than the metals. So when it reacts with the metal, it pulls the electron from the metal. It will pull the electron from the metal, so it becomes negative 1. With metal, it pulls the electrons, so it becomes negative 1. But with non-metals, many of the non-metals, or most of the non-metals, they have higher electronegativity. Not all of them, but most of them, they have higher electronegativity. Okay? So they will pull the electron from hydrogen. They will not pull it completely, because they, in this case, they share electrons. Like when we say H2O, or CO2, H2O or HCl. Okay, these are covalent bonds, and these are molecules. Okay, so in the molecules or in the covalent bond, they share electrons, but they don't share it equally. They do not share it equally. They share it. The stronger one pulls more, so the stronger one becomes more negative. The weaker one becomes more positive. So non-metals, they are strong. In general, non-metals are strong elements. They are stronger than hydrogen. So when they react with hydrogen, they pull the electrons more than hydrogen, so hydrogen becomes positive 1. Do you understand this issue of hydrogen? So with metals, it's negative 1. With non-metals, it's positive 1. The last one, the last rule, it's for something called the polyatomic ion. Polyatomic ion is an ion, but it's not a single element ion. It's not a single element. It's not a monoatomic ion. Monoatomic is like the first one I talked about, like sodium, magnesium, whatever element that has an ion. But the polyatomic means it has multiple atoms. Multiple atoms, like the SO4. SO4, it's called sulfate. There is a table in the textbook, table number 4, page 569. It has the, it's this one. Okay, that's table number 4. It has the polyatomic ions that we will focus on this semester. So it has ammonium, acetate, chlorate, hydroxide, nitrate, carbonate, sulfate, phosphate, and I added the bicarbonate. These are not compounds. These are not compounds. These are polyatomic ions. Polyatomic ions means it's not stable. It needs to react with something, with whatever element or whatever another ion to form a neutral compound. Like for example, the bicarbonate, this bicarbonate. It has a charge -1. It reacts with sodium. So when it reacts with sodium, it produces sodium bicarbonate. The sodium bicarbonate is the baking soda. This white powder that you use at home in the cooking and this stuff. Okay? That's sodium bicarbonate. It's the polyatomic ion, which is the bicarbonate, okay, with sodium. Okay? So again, the polyatomic ion is not a neutral compound, but it's an ion. And the charge of this ion, you can find it here in the table. So these are like the most famous polyatomic ions. So let's go back to the rules and see why do we need it. The rule says what? Sum of oxidation numbers. The sum of oxidation numbers equals what? We said before it equals to 0. No, but 0 for the neutral compounds. These are not neutral compounds. These are polyatomic ions. So for the polyatomic ions, the sum of oxidation numbers equals the charge. It equals to the charge. So for the sulfate, the charge is -2. So the sum of oxidation numbers is -2. Let's see two examples on the rule number 11. Example number 1. What is the oxidation number of carbon? In the acetate, HC2H3O2, okay, and it has a charge -1. Its charge is -1, and it's a polyatomic ion. So what should we do? We should say the sum of oxidation number is the charge, which is -1. Then let's go back to the rules. What is the oxidation number of oxygen? Oxygen is -2. What is the oxidation number of hydrogen? Oh, hydrogen might be +1 or -1. In this case, in this polyatomic ion, is it +1 or -1? What do you think?
Positive.
It's +1. Why?
Because with non-metal like oxygen and carbon.
That's right, because it reacts with non-metal, so it's +1. Carbon, he's asking about carbon. So we'll call it X. The oxidation number of carbon is X. I don't know it. So I will say I have 2 carbons, so 2 times X. And I have 3 oxygens, so times 1. I have, 3 hydrogens, not oxygen. 3 hydrogens, that's 3 times 1. And I have 2 oxygens, so it's 2 times -2. Times -2. And the sum equals the charge, which is -1. Solve this equation, so 2x plus 3 minus 4 equals -1. So x is what? What's x? Zero. That's right. So you will find x is 0. That means the oxidation number of carbon in this polyatomic ion is 0. Okay, it is 0. The other question. The overall charge on the polyatomic dichromate ion, that's a polyatomic ion called dichromate, it's -2. -2. Okay? What is the oxidation number of chromium in this polyatomic ion? So we have Cr2O7 and its charge is -2. So I will say the sum of oxidation number is -2. I know the oxidation number of oxygen is -2. And chromium, I will call it X. So chromium is 2 atoms, 2 times X, 2X. Oxygen is -2, and there are 7 atoms, so minus 2 times 7. It gives you the total charge, which is -2. So X is what? X becomes what? Huh?
6.
Positive 6. Positive 6. That's right. That's right. Understand it? So in the neutral compounds, the summation equals 0. In the polyatomic ions, the summation equals the ionic charge. The polyatomic ionic charge. Let's move to something else. How to write the formula of the ionic compound? How to write the formula of ionic compound? Like let's say I have Mg, not Mg, we need the formula. Like magnesium chloride. Okay? So how to write the formula of magnesium chloride? First write down the metal, which is magnesium, the symbol of magnesium. Then write down the other one, the non-metal, which is here chlorine. Okay? Look at the charges or the oxidation numbers of both of them. Chlorine has oxidation number of what? Chlorine. Negative 1. Magnesium? Plus 2. So then you don't know what. What's the problem here? What's the problem? You don't know how many atoms of magnesium with how many atoms of chlorine, so they will make a match. But I know that the summation of oxidation number is 0. So if you sum all the oxidation number, it must be 0. So try to sum the oxidation number. X times 2, that's 2x. And y times negative 1, that's negative 1 times y, that's negative y. That must be 0. So what are the values of x and y? What are the probable values of x and y? What are the values of x and y to fulfill this equation?
X I think is plus 2 and y is also 2. Minus 1 times y is...
So you said x equals 2? You said x equals 2 and y equals 2?
No, x equals 1.
No, but here 2 times 2 is 4. Minus 2 times 1 is 2. So 4 minus 2 is 2. It's not 0. You cannot do that. You cannot do that. That's not right. That's not right. There is a very simple method. Of course, the mathematical method is to find what we call the LCM of the two numbers. The LCM is the least common multiple. The least common multiple here is 2. 1 times 2 is 2. And then divide this least common multiple divided by this number gives you the x. And divided by the other number gives you the y. So the x equals 1 and the y equals 2. So it becomes Mg1Cl2. That's the magnesium chloride. There is some simple method that you can do very easily. Take this number, put it here. Take this number and put it on the other side. Okay? And it works. It works. Especially for the small numbers. Okay? Let's see something else. Lithium nitride. Let's take the lithium nitride. Lithium nitride. Lithium is Li. That's number 3 in the periodic table. Nitride is the nitrogen. So lithium has oxidation number of what? What's the oxidation number of lithium?
Positive 1.
Positive 1. And nitrogen?
-3.
Negative 3.
Minus 3 or negative 3. So the problem now, how many lithium with how many nitrogen? Get the LCM, divide it over this one, gives you X, divided by the other one gives you Y. Or this number, take it here, and the other number, take it to the other side. So it becomes Li3N. That's the lithium nitride. This is the lithium nitride. Okay? You can do it.
To neglect the side, right?
Neglect the what? Yeah. Like we are talking about a number. Okay? So that's the number of atoms. So there is no sign. Okay, guys? So that's how we write the formula. There is something else. How to name ionic compound? The inverse. How to name the ionic compound? If I give you NaCl, if I give you MgCl2, if I say Ki, if I say L2O3, how to name these compounds? We start with the first element. We start with the metal, which in the first case magnesium, second case potassium, third case aluminum, fourth case sodium. So you start and write down this name. And for the second part is the non-metal. You start with the name of the metal, but you take the first part or the first section of the name, okay, and you replace the second section of the name by IDE. IDE. Okay, like for example, oxygen becomes oxide, phosphorus becomes phosphide, nitrogen becomes nitride, sulfur becomes sulfide, fluorine becomes fluoride. You know the fluoride in the toothpaste? Chlorine becomes chloride. Iodine becomes what? Iodide. Okay, bromine becomes what? Bromide. Carbon becomes what? Huh? Carbide. Okay, and so some names and some elements take care that it has another name which is carbonide, but that's something else. Okay. Anyway, so that's the second part. So let's name the first element, MgCl2. Who's going to tell me what's the name of the MgCl2? Huh? What's the name of Mg?
Magnesium chloride.
Magnesium chloride. The second one, Ki.
Magnesium.
No, that's potassium.
Iodide.
Potassium iodide.
Potassium iodide. Third one,
Aluminum.
what is it?
Aluminum oxide.
Aluminum or aluminum oxide.
Aluminum oxide.
Aluminum or aluminum oxide. NaCl. The last one,
Sodium chloride. Sodium chloride.
chloride. Sodium chloride. Okay? Sodium chloride. That's working fine.
Of elements.
Excuse me?
The number of elements we see in the covalent, right?
That's a good point. The number of elements like MgCl2, Al2O3, where are the number? In the ionic bond, we do not pronounce it. The number of elements are not pronounced in the ionic compounds, but we will do it in the covalent. We will do it in the molecules. In the molecules, in the covalent bond, we will tell the number of atoms. But in the ionic compound, we do not. So next time, inshallah, we will study the covalent compound, the covalent bonds, and we will mention the numbers. There is something else here. If the elements, if the metals are transmetals, actinides and lanthanides, or lead, okay, these elements, they have a problem. What is this problem? They have more than one oxidation number. They have more than one oxidation number. Like iron, for example. The iron sometimes it works as iron 2, positive 2, or iron positive 3. Sometimes it loses 2 electrons and sometimes loses 3 electrons. So they call it iron 2 and iron 3. So its oxidation number. Sometimes it's positive 2 and sometimes it's positive 3. Okay?
Like lead, right?
Like what?
Lead is like iron.
Lead also. Yes. So here we have in table number 2. Table number 2. Did you lose the PowerPoint? Okay. So in table number 2 here. Table number 2. It has some special atoms, and it gives you the oxidation number of these elements. It has multiple oxidation numbers. Like copper, it has 2 oxidation numbers, 1 or 2. Iron might be 2 or 3. Chromium might be 2 or 3. Lead might be 2 or 3, 2 or 4. That's why when we write down the name, we have to write after that the oxidation number. The oxidation number. Oxidation number. We write it in Roman numerals. You know the Roman numerals? Numerals? I, double I means 2,
V.
3,
Yes.
and then 4,
IV.
and then 5,
IV.
and then the VI is the 6. Okay? So these are
Yes.
the Roman numerals. So we write it down after those special ions. After those special ions. Like for example, let me give you some examples. Fe2O3. Fe2O3. I will ask you a question. What is the oxidation number of iron? What is the oxidation number of iron in this compound?
3.
Huh? I know that oxygen is negative 2. I know oxygen is always negative 2, or usually negative 2. Iron, I will say it's X, because I don't know. It might be positive 2 or positive 3. It has 2 probabilities. So I will sum all of them and equate it to 0. So the sum of oxidation numbers is 0. So I will say X times 2. X times 2. And 3 times negative 2. So 2 times 3 is 0. So X is what? Is 3. So X becomes positive 3. So the oxidation number of iron here is positive 3. So if you want to name this compound, you say what? That's iron 3 oxide. Iron 3 oxide. Let's take another one. FeO. FeO. That's also iron oxide. But which iron oxide? Let's see. Oxygen is negative 2. Iron is X, equated to 0. So 1 times X minus 1 times 2 is 0. So X is 2. X becomes 2. So if X is 2, that's iron 2 oxide. So the difference between iron 2 and iron 3, that's Fe2O3, and the other one is FeO. They have the same elements, okay, and both of them, they are ionic bonds. But iron, it has dual oxidation numbers or dual behavior here. It has dual behavior. Might make positive 3 or positive 2, and in both of them it's stable. It feels happy with both of them. Okay? Let's see something else. Write down the formula of, where is it? Okay, okay. Lead 4 phosphide. Write down the formula for lead 4 phosphide. Lead is Pp. Phosphorus is P. Look at the lead. Look at the lead. Lead here is what? It's lead 4. He told us it's lead 4. So it has oxidation number 4. And the phosphorus, look at the periodic table. Look for the phosphorus in the periodic table. What is the oxidation number of phosphorus? Minus 3. So how many atoms of lead with how many atoms of phosphorus to make it 0? Huh? Take this number here, this number here. It becomes Pp 3 P4. Right? That's right. Understand this one, guys? Do you understand it?
Yes.
Somebody might say what? Somebody might say, can I put the x equals to 6 and y equals to 8? It achieves the equation. If you put it, if you say Pp6 and P8, that's also right. But we have to simplify it. We have to simplify it. 6 and 8, they are not the simplest form. So we need to divide over 2. The 6 becomes 3 and the 8 becomes 4. Okay? So in case of ionic compound, we can simplify the numbers. But in case of covalent bonds, never, never, never simplify the compound. Again, never, never, never. Like C2H6. Ethane. It's called ethane or what? Ethane, right? The ethane. C2H6. That's covalent bonds. These are covalent bonds. 2C with some hydrogens. Okay? We will study it next, but I'm saying from today, do not simplify it. Like you cannot say it's C1H3. You cannot say it's CH3. That's something else. Okay? We just simplify in case of what? Ionic compounds only. Ionic compounds only. Okay, guys? Do you understand it? Hello?
Yes, I understand.
Yes, yes.
Okay, let's take a very last example before you leave. Can you name this? Magnesium, huh? This one, the first one. Magnesium what?
Fluoride.
Huh? The last one.
Fluoride.
The last one. Lead? Huh? Lead? No, it's not lead chloride. It's lead something chloride. Lead what? Lead 2 or lead 4? There are 2 or 4. That's lead what? That's lead 4. That's right. What about UCl? CuCl. Copper? Copper what? Cu is copper. Huh? Copper what? It's copper something chloride. Copper 1 or copper 2? Copper 1. From the balance, it's copper 1 chloride because chloride is positive 1. So copper will be positive 1. Okay? And also here in the last one, chlorine is 1. So the lead will be positive 4. Okay, guys, that's enough for today, and we will continue, inshallah, next time.